Thank you for joining us here on Vital for Colorado Radio. I am your on-air producer, Jon Ekstrom. We are part of the Connect and Collaborate Network. Joining me, as always, is our host, our chairman and CEO, Peter Moore.
John, thanks a lot. I'm looking down at Season 3, Episode 24. If my math is correct, we must be over 70 shows so far.
That's right, 70 hours of radio.
So, thanks a lot.
Thank you, Peter. This is always the highlight of not my week, but my every 2 weeks. So it's a pleasure to get together with you and speak to all these people of interest and prominence.
Well, Vital for Colorado is a nonprofit organization, and we've been in operation really since the spring of 2014. We have a board of directors, about 14 people. I'm the CEO and chairman of the board of the organization, and what we try to do is we try to educate and advocate about various energy issues, and it's endless about what one can talk about. We also try to build our coalition, which is now over 87,000 people and over 1,000 businesses, and probably the most significant number is that we have over 180 trade associations in the state of Colorado, which I think really might be almost every one of them of some size. And so we try to be the voice of business to talk about reasonable energy policy. And in Colorado, it's always subject to change. And I'm very, very happy to have you here, Hans, because you're the Chief Technology Officer of EcoVapor Recovery Systems. And I have a sense as to what you do, but why don't you sort of introduce yourself a little bit, I guess your background, and tell us about EcoVapor.
Yeah, Hans Mueller, welcome.
Thank you. Thank you, Peter. Thank you, John. Happy to be here. Really is a pleasure to be part of this. I appreciate the invitation. EcoVapor is a unique company in a few different ways, but really the genesis, why are we here? We are here to combat the issue of waste. Waste is something that I never feel good when I see, whether it's on small scale or industrial. And EcoVapor has unlocked through technology, through developing technology. This wasn't something that we found. This was a solution we had to create. We've been able to allow operators to develop zero emissions well sites at a profit, a significant one at that.
So that's pretty astounding when zero emissions, and if you think about all the pipelines and storage facilities throughout the country, that's a lot of savings.
It's a very ambitious goal, too.
Well, you got to start small. It's definitely like eating an elephant.
One bite at a time, huh?
Yeah. Well, in this case, it's one MCF or 1,000 cubic feet of natural gas emissions that are diverted from going up in the air at a time.
Wow.
So how about a before and after, before the deployment of your technology and after? That probably would be good to understand because, for large industrial operations, I know that the oil and gas producers don't like to allow sellable product to go out in the air, but when you have very, very large systems, it's probably almost impossible to stop. So what was the state of the art before the development of your technology, and then what does your technology do to improve upon that?
Well, there's been a development over, especially in Colorado here, in about 11 years now. In 2007, the Denver metro area Front Range wasn't adhering to the NAAQS, the National Ambient Air Quality Standards. These are set by the EPA on a federal basis, and if an area, particularly the one I'm talking about, the Front Range, is not in adherence to that, it's up to that state to come up with a plan to get back into adherence with those standards.
Right.
In 2007, the state implementation plan included a change in operations for oil and gas where flash emissions, this is essentially any propanes, anything that's in between natural gas and oil, essentially if it boils out of the oil due to a pressure drop in the oil tanks, they used to just be vented into the air.
Right.
And that was the practice in other states until the federal Quad O regulations hit.
And that's understandable from a safety point of view because you need to maintain pressure. It's you can't allow the pressure to become too high because of that boiling process.
That's right. Yeah.
But it's not great for the environment to allow, I guess, fugitive hydrocarbons to get out in the environment.
That's also right. Typically, tanks designed to hold produced oil or condensate, they have a maximum allowable pressure of 1 psi. So to your point, they had to vent the emissions that flashed out, what was a liquid that turned into a gas that takes up a lot more space, so that had to be released in one way. It used to just be vented into the air.
Right.
In 2007, that's when Colorado mandated that for the majority of new production facilities, that 95% control of those emissions was mandatory. Be that, and they can be accomplished any way. That could be through recovery process. And in 2007, the technology wasn't quite caught up to allow for that. Another way to do it is to essentially incinerate, to burn it with a 95% efficient or higher than that burner.
Because that's going to have a lot less impact on the environment than just releasing it in its gaseous state.
Absolutely, yeah. It's been well established. Science has been well established that methane itself is about 14 times more potent of a greenhouse gas than CO2. So it definitely made sense, especially at that time, given the technology available to operators, to do something about it. And they also had to act quickly. What's interesting, though, looking back, is that flaring was adopted as essentially a standard operating procedure. Instead of during like an upset condition or something, flaring is just common practice in the oil field. And again, I think it comes down to the technology that was available at that time. But
and almost a convenience. And, I remember at the time in North Dakota, there were some infrastructure concerns. Like, you don't want to just flare that off, because ideally you could sell it.
Right.
But up there wasn't the natural gas infrastructure to get it to market, so companies couldn't necessarily make money on it. Is that fair to characterize it that way?
Yeah, there's multiple reasons that inhibited the sale of essentially this product. They've worked really hard to get these hydrocarbons out of the ground. It never really sat right with me to see it going up in the air, whether it was being burned or not. So what does it look like when EcoVapor
Actually, just before we talk about, I guess, the improvements since 2007, but on the other hand, if you can convert methane and essentially reduce it by 93% by burning it and turning it into CO2, that's a heck of a win. So flaring made a lot of sense.
Absolutely.
At that time, and
in many cases it still does.
And people look at flaring and say, "Oh my goodness," but they're not really thinking of the conversion of one gas to another, and what that does to the environment. So, but that was a long time ago. That was 2007, and I recall I've been in Denver since '78, and just driving around, mostly in Commerce City, I'd see flaring all the time, and I always wondered about that. So I guess that's almost a direct function of these 2007 laws?
Yes. Before,
wow.
Yeah.
I didn't realize that.
In many instances, it was just being vented prior to that.
Yeah.
But yeah, as you're saying, flaring makes a lot of sense back then and in many cases today. Last week, we had a rather large operator out of state contact us, see if we could help. And we told them that the best solution to them was probably to light a match and flare it. Economics are at the forefront of EcoVapor's value proposition. In many cases, most of them, in fact, it makes clear sense from an economic standpoint to recover this product. Like I said, they've worked hard to get it out of the ground. Might as well sell it if you can.
So I just wanted to make that sort of comparisons, and I'm sure there was a phase-in period, so it's not exactly 2007. So I don't know how many years. Was it 2-3 years to phase in those regulations, or how long?
It was 2007.
It was just that year.
Operators had to jump.
Wow.
Yeah, and I think that also led to the widespread adoption of flaring. It's
okay.
In terms of the technology hurdle, it's not very high. It's grown a lot in terms of efficiencies and reliabilities, safety practices. These have all been developed over the last decade to the level that they are right now. However,
So things are better now in 2018, but to look at 2007 is the same number. But I just want to create a baseline because it's
Sure.
striking to me. The flaring, what people look at, and they think is that, oh my God, that's the most environmentally wrong thing to do. But in reality, I guess compared to venting, the numbers had to be over 90%. I guess reduction of harmful greenhouse gases.
Yeah.
So flaring was a very good thing in comparison to venting.
absolutely.
And now you're talking about zero emissions.
That's in
As a
less
goal.
than 2 weeks, it's going to be 2019.
Yeah.
And it's one of the things I try to do at the end of every year is understand where we are, on a personal basis, but also as a society. And thinking back to the Future, in 2015 we were going to have flying cars.
Right.
There's been a lot of other advancements, and
We do
perhaps
have
it's
flying
something-
cars.
There you go. We're living in the future, so we should
That's
act
right.
like it.
So I'm interested in terms of the way EcoVapor come into existence.
Sure.
Right? It's interesting to me, were you responding more to rule changes or legislation that was enacted, or did you see an economic value proposition here? You go, there's money to be made here by capturing this, and so how do we do that? So take us through the origin a little bit.
Okay, absolutely. I graduated from Colorado School of Mines, mechanical engineering degree.
My hometown.
There you go, Golden, Colorado.
That's it.
It's a fine place.
Yeah, it's a thin slice of all right.
I'd agree. Sometimes, most days, I miss living there.
Sure.
Prior to leaving mines, though, I had an internship down in South Carolina where my responsibility was to manage a project really from inception to implementation, where we were powering a cement kiln. We were delivering fuel to a cement kiln that was comprised entirely of waste streams, both consumer, industrial, anything from hazardous waste from industrial processes to rancid butter, off-spec ink, off-spec shampoos,
Wow.
you name it. The goal was to blend these streams into a specific fuel spec that included density, particulate size, heating value, everything like that. And I learned a couple things from there. One is you can do good things with waste. You can offset any other type of fuel, any other type of traditional fuel. But the real eye-opener for me was the business model. You pay your garbage man, right? Mm-hmm. So in this model, there was cash in from the collection of these waste streams, but then also there was cash in from delivering that product that we were making, and that was a game changer for really my outlook on the world. I came back to mines for my senior year after that. Was lucky enough to be assigned to the senior design project that I really, really wanted. It was flare gas capture and utilization, but it was the application was for landfills. And while we did come up with a way to capture and utilize gas, issues we ran into were gas volumes. The heating value of the gas, there's a lot of air in it. It's not very rich, if you will. It is, however, full of contamination. In this case, siloxanes. They will tear up any rotating equipment that you try to put through it. So there were these challenges, and then probably the biggest one was, what do we do with this? Okay, great. We've captured this. And now we have it. What's the end goal? What's the benefit that we can provide from capturing this, aside from just environmental?
Sure.
Environmental issues are near and dear to me, but I have no confusion that without an economic case or regulations to drive it, good luck.
Right.
So we looked into the PURPA laws, the Public Utility Regulatory Act.
Mm-hmm.
Essentially, it said that they are what allow people with solar panels on the roofs to reintroduce that power into the grid. Same
sure,
if you're
yeah.
running a generator off of landfill gas. But at 7 cents a kilowatt hour, it was never going to.
Not a real strong value proposition.
It wasn't
I
going
get
to
it,
make
sure.
sense. People weren't going to implement it, especially on the scale that I was looking for. So we
So
all
you pivoted.
Well, I pivoted with some help. In this case, blessed that my father, who was had recently stepped down as chairman of the Colorado Oil and Gas Conservation Commission, essentially told me, look north, my son. He knew that the oil field was experiencing their own issues, but the challenges that we ran into on the landfill gas application didn't exist. All of a sudden, very rich gas.
Right.
Not contaminated with siloxanes or other things that come out of garbage that can be damaging to equipment. And perhaps the biggest advantage that I saw compared to the experience that I had prior was that the question of what do we do with it was inherently taken care of.
Yeah, there's
Yeah,
a transportation system right there.
Right there.
Compression, dehydration, all that.
Put it in the pipe.
Yeah.
So oil wells looked different when the company was started. The shale, the horizontal wells in shale revolution was just taking off.
So when about was this?
2010.
2010, okay, yeah. Not thoroughly a vertical world, but a much more vertical. I mean, that was right around the time of EOG's Jake well in the DJ.
Exactly.
And Noble's Gemini well, which were both game changers in their own way. When EOG drilled that well, everyone goes, wow, there's a lot of oil up here that we didn't realize we could tap into. And then Noble's Gemini well was one where they go, wow, we can do really long laterals.
Yep.
And from there, I mean, we were off to the races. So, yeah, the opportunity was before you.
I was taken out to the Gemini facility after we deployed our first prototype.
Okay.
The challenges that we were initially targeting revolved around production characteristics, essentially the profile, vertical and directional wells. They are under plunger lift. The reservoir that they tap into, not being a horizontal well, wasn't that large.
Right.
After it's depleted, they'd have to shut the well in for a while, let the reservoir pressure up, and then they'd open it up once pressure was there to lift all the liquids. Well, the liquids were coming up all at once. And we spoke about flash gas earlier. There was so much flash gas produced in these oil tanks that the tanks were actually starting to break at their welds.
Oh, my.
So we tried to approach this. Well, an easy solution would have said, size the equipment so that it can handle the peak volume, the peak rate of volume production, and it'll handle it. The trouble is now you have a huge and very expensive piece of equipment that might run for 2 hours a day. So the challenge that we approached and solved was, how do we do more with less? How can and that's a theme at EcoVapor. How can we do more with less? We used smaller compression equipment, but sized essentially a surge tank on the front end, and we were able to eliminate the overpressurization issues. We were able to capture this, but that's when we ran into probably the biggest challenge that EcoVapor's ever had, and also what's laid the foundation for our business going forward. We did find that there is a contaminant in this stream, this waste stream, this potential revenue stream. There's oxygen inside of it.
Not what you always think of as a contaminant, right?
I personally feel great about oxygen every time I breathe.
This is going to be the hottest take in the history of this show, Peter. Oxygen generally good.
I don't know. I think of oxygen as being a radical molecule that causes rust.
That's what it does. It's
Spoken like a true car guy.
I'm not sure. I mean, I think it's okay, but
You think it's merely okay?
Yeah, but
okay, now that is in fact a hot take. Oxygen, merely okay. On the scale of elements,
well,
yeah.
I just wanted to calm you down a little bit. It's not all good, and
well, and that's exactly right.
But that's what you're getting to, is that oxygen, from a chemical point of view, is very volatile.
Right.
When match with almost anything else, and it's also easy to join other things too. So that's why it's called radical.
Well, and there are times where oxygen has perhaps wandered into the wrong club, and everyone in the club looks and goes, "You don't belong in here. This ain't your club.
Well,
Get out of here."
That club is midstream gathering pipelines, and a lot of
Way to bring it home. That was solid work.
Hey.
So I hear smaller
Club to be in.
compressors, I hear bladders, and I hear a process to deoxygenate the stream.
and the
Are those the three elements? There's probably something else.
Almost on a historical basis, that was our progression.
Okay.
But why is oxygen even an issue to these folks? You hit it on the head. Corrosion, essentially.
Right.
It corrodes the infrastructure, which is the pipeline's asset. It's not so much of a Hindenburg scenario where a little bit of oxygen could cause things to turn orange.
It actually can be a poison to human life in too great a quantity.
Well,
Yeah.
let's avoid that if we can.
Yeah.
Coming up on Vital for Colorado Radio, the dark side of oxygen.
But that's
You got me going.
well, that was the challenge that we run into. I lied to our first original client about how many people there were in EcoVapor. I think I said 4.
Well, now we're getting
like that.
somewhere. Now we're talking about lies and the dark side of oxygen. This is the last show of the year, baby.
That was.
It's time for some scandal.
The one time I bent my ethics was to say, and it got us past the first hurdle. And I approached a producer or our first client and said,
As your lawyer, I would suggest that you say I was more of a marketer than an engineer that day.
statute of limitations is well behind me at this point.
Yeah,
but
He'll be the judge of that. I promise you he will.
maybe we should talk after, Peter.
Yeah.
But I had this solution. I went in and said, "Hey guys, I have this great idea. What do you think? This was the bladder. This was how can we do? How can we resolve this issue for producers?" They looked at me and said, "Yeah, that's great. Prove it." 3 months later, I showed up with our prototype. Everything worked well, but that's when we discovered that O2 was an issue, and that's that was the one that we had to solve, and we've done so in a unique way.
Yeah, I'm just curious. How did you discover that O2 is an issue? What was your pathway to that?
What was the tip-off, yeah?
It came at me from a couple different directions. Gas plants in the basin had recently had to shut in for months at a time due to corrosion issues. Oxygen, being as reactive as it is, messes with their processes to remove any H2S, carbon dioxide, etc. So it was well known. It was kind of a well-known thing. We hadn't quite quantified it at that point. I remember trying to keep air out of these tanks by sealing off every threaded connection, seeing, hey, how can we keep it out there? And it turned out that was not the right approach. O2 is going to get in wherever it can't. Forgive my crude analogy, but the best way I know how to describe it is that oxygen is like a fart.
Oh, really?
Somebody does that in that corner of the room, it's going to go where it's not. It comes down to high school chemistry with partial pressures, but essentially you have 3 psi of oxygen knocking at any door where it's not already on the other side. So even if there's positive gauge pressure inside a vessel or a tank, oxygen can diffuse into that even if there's a pinhole leak. It can essentially, it does swim upstream regularly.
Wow.
So I had to change our approach.
It's a remarkable element in that there is a dark side and an evil side to it. It is also fart-like.
Thank you.
So this is remarkable work we're doing here. So Hans, we're going to talk in our next segment about quite a bit. We're going to talk a little bit more about regulation. We're going to talk about the evolution of EcoVapor. We'll talk about a number of things. Peter, you told us a little bit about Vital for Colorado. Where can we find Vital on the web?
On the web, you would go to spelled out the words vital, F-O-R, Colorado.com.
And if you go to the Learn tab, you can see all 72 episodes that we have done. Go to videos and podcasts. You'll see a list. We've had some fantastic guests, people from elected office, leadership in business, chambers of commerce, people of national prominence, and Hans Mueller.
Woo!
Here from EcoVapor Recovery Systems, you are the Chief Technology Officer. Peter Moore is our Chairman and CEO of Vital for Colorado, also an attorney at Robinson Waters and Odorcio. We'll be back with lots more in the second segment. Thank you for staying with us here on Vital for Colorado Radio. I'm your on-air producer, Jon Ekstrom. We're here with Hans Mueller, the Chief Technology Officer with EcoVapor Recovery Systems, and, of course, our host, the Chairman and CEO of Vital, Peter Moore.
Well, thanks a lot, John. Probably one of the biggest environmental issues in 2019, just around the corner. The word methane is in the air, so to speak, and people are afraid of it and want to capture it, want to stop it from leaking. First of all, what is methane, and what is the role of your technology to solving the problem of methane?
Sure.
Excessive methane.
Oh man, well,
I will too broad a question.
No, I will try to avoid going into too detailed engineer speak. So pull me out if I need to, please. But what is the role of methane? Why is it important to capture it? My immediate reaction is that methane is part of the story. It's not the whole story. Methane itself is the shortest chain hydrocarbon on a broad spectrum. It only has one carbon atom, 4 hydrogens, and it builds up from there. As such, it's probably the hardest of the hydrocarbons. It's probably the hardest one to break. So it takes the most energy for it to react with something else. For example, propane, 3 carbon atoms, a lot easier to get to react, whether it's through the EcoVapor's process or via sunlight. But methane itself is it's not categorized as a volatile organic compound, so its impact from an environmental standpoint is strictly as a greenhouse gas. We said earlier it's about 14 times more potent than a CO2 molecule. That is the reason to keep it in the pipes, to keep it in the tanks.
Because when it gets up there, it doesn't break down.
That's not for a long time because it's so stable, because it's the shortest one.
Certainly.
However, I said that's part of the story. Most of the methane on oil and gas production location, you don't need to worry about because it's already going down the pipeline. You know, there are frontier wells without pipeline connects.
Sure.
That's its own story. But most of the methane is already going down the pipe. It's the longer chain hydrocarbons that aren't yet oil. It's really in between natural gas, which is primarily made up of methane, but it's the ethanes, the propanes, the butanes, the pentanes. They exist as a liquid when the gas, the methane, is being gathered, because that's done at elevated pressure. It rides on whatever the pipeline pressure is at the time. But those they're in the liquid phase at that point. They get sent over to these oil tanks, which operate at just above atmospheric pressure, maximum pressure of 1 psi. That's where these ethanes, propanes, pentanes, butanes, that spectrum, it will change phase so that now it's a gas when they're gathering a liquid. It's liquid when they're gathering the gas. It's a gas when they're gathering the liquid.
Okay.
So what are we flaring? What used to be vented? What is being flared? It's primarily this very rich stream. And it's also even more detrimental from an environmental standpoint should it escape, because they are volatile organic compounds.
And all those are sellable products also.
Oh, in fact, it's very sellable.
Right.
It's the highest value gas stream on a production location. People that have been in the oil and gas industry their entire careers, they literally don't believe me when I say how rich the stream is that EcoVapor's processing and allowing to be sold. That is a big component of the economic proposition that EcoVapor does offer. But going back to the environmental side, those volatile organics, they are a precursor to ground level ozone. If VOC, volatile organic compound, propane plus, if that comes in contact with NOx, which interestingly is a byproduct of flaring, especially during wintertime, those can combine and form ground level ozone, which burns your lungs.
That would be nitrogen oxide?
Correct, yeah, NO2, NO3.
Or oxides?
Compounds around those lines.
And ground level ozone, that's O3?
Correct.
Okay. Another poor incarnation of oxygen. Despite the propaganda from all those fat cats at Big Oxygen, giving us the runaround about how great oxygen is. You have it in too many quantities. You have it in the wrong chemical composition. It's O3, burns your lungs.
Well, we like ozone in the right place.
Well, certainly. But ground level ozone?
No.
Again, this is not your club. You don't belong here.
Well, that's true, and other people would agree with that, including on a federal level.
Oh yeah.
And for example, because of the air quality issues that the Front Range experienced in the summer of 2018, the metro area up and down the Front Range actually is slated to move from moderate non-attainment with the National Ambient Air Quality Standards to severe non-attainment.
Oh wow.
As a result, a Title V operating permit is going to, the threshold is currently 100 tons per year of emissions. That's going to drop down to half of that, 50 tons. So everybody's going to need Title V. Well, as well sites consolidate, as pad drilling consolidates more wells onto a specific location, that is another positive from really any consideration. Environmental, economic, consolidation leads to efficiencies, but it also consolidates your emissions into one facility. So as oil and gas facility design has advanced in the past decade especially, we're concentrating those emission sources, and so when I say everybody, that's not accurate, but many production facilities of that size and scope will fall under Title V's, especially once that threshold is dropped by 50%. Those usually take about a year to get through regulatory agencies, and I'm happy to say that EcoVapor's most popular product, our 02 E300, is good for about 300,000 cubic feet a day. That will reduce emissions by about 100 tons per year.
Wow.
What's the function, and this is just a random thought that popped in my head, in terms of altitude, the difficulties and the pressures available at 5,280 compared to some place like Baltimore, for example, sure. In terms of this non-obtainment, I guess you called it, right? Mm-hmm. So what role does altitude play? Altitude and pressure.
Altitude and pressure, I can't immediately think of a direct role that plays, but with altitude comes different temperature gradients. For example, in Colorado, higher altitude, we're going to have more snow on the ground than, say, the example you gave, Baltimore, or maybe Florida. But when we're talking about how ground level ozone forms, well, we have VOC plus a NOx compound. That's not enough. You have to add energy to it. And sunlight, especially on snowy days, can cause more formation. Right. That's how I'd correlate that, though.
Okay, there's some correlation. I was trying to figure out what it was, because I know that it's very, very difficult for Colorado to meet the standards. And,
I can't say that
people have said that for a long time.
Oh, sure. And I can't say that there isn't other factors in there.
You just haven't looked at them.
Yes. Yeah. I'm if they exist, I'm unaware.
So, Hans, one thing I'm curious about is, you've got this problem, and you've got flaring, which is sort of entrenched as the way that things have always been done, and there's always a hesitancy to change the way business is done.
Yes.
It's like, this is the way we've always done it, and it's convenient and it's easy, and flaring is one of the easier things that you can do, that at the time solved the problem that it was designed to.
Yep.
What was the challenge like trying to get this into the hands of operators? And were you almost accused of being snake oil salesman, because it's like, oh, really? You can save us money, we can meet these environmental standards, and we get to turn a profit on these products. So what was the initial value proposition like, and was the sale difficult?
It depends on who the customer is. And it really depends on their awareness and their, in some senses, sophistication and understanding of gas marketing and the economics behind it.
But I guess my point is, how much proof of concept did you have to do?
Oh, lots. Lots.
Because, I mean, like, you're dealing with engineers here, other engineers, who are going to want to say, you know, show it to me, and also I don't want to pay for it yet, right?
Especially early on, EcoVapor's equipment was far more complicated than a combustor or a flare.
Sure, yeah.
Significantly. Oil and gas, has a lot of mental inertia, and that makes sense. It is a feat what operators are able to do.
Oh, it's a miracle.
It's, not far off of that at all. It is...
Well, Peter, we've done 70-plus hours now, and we've talked to a lot of people in oil and gas. And I think what we found is the more you learn about this, the more complicated it gets. Is that fair?
But also recently, I have seen many people that embrace technology and are real acolytes and believe that it's going to be a brighter and better future through the application of technology. And especially during the last 3 to 4 years with the economic downturn, there was a great need to develop greater technology.
Yeah, and greater efficiencies.
And we're seeing that as
I like the story of technology solving problems and also market-based solutions, as opposed to top-down regulatory attempts, because the guys in the State House are guys and gals are nice guys, but they're not scientists. And I would prefer people that are focused on the profit motive and scientists getting together to solve a problem. It sounds to me, which is what your product line is doing.
And we've gotten better at what we do, significantly. Comparison is our first generation equipment occupied plot of real estate 8 feet by 40 feet. It was able to handle 17,000 cubic feet. Our products today are able to handle 1.2 million cubic feet at a footprint of 4 feet by 6. So 8 by 40 down to 4 by 6, 17,000 up to 1.2 million. We're working on something much, much larger right now. I'll leave it at that. But I think that also oil and gas as an industry it's a risk-based but risk-averse industry. So once all this hard work, all this development, all these mistakes have led to the completion technologies, everything that we see out there today, like you said, it's a miracle. It's no surprise to me that the industry is going to fiercely defend what they know works. And to your point, there are early adopters, just like any other technology, any other industry. There will be people that see that, are willing to try it, maybe have different motivations than another group, and that can come from a variety of different sources. But the one example I'd give is in 2012, a facility engineer who I only have the utmost respect for, very objective, smart person. He told me, and it was a blow, it was like a gut punch, saying that operator would not be standardizing EcoVapor equipment on their locations due to reliability concerns.
Oh.
Hey, I said, we were a lot more complicated than a flare. Today, our most popular equipment has no moving parts. On a nationwide basis, we're deployed in every major production basin in the U.S., and our uptime on this product line averages above 99.7%.
Wow!
So we've
what's
gotten
the
better.
time period to pay for the product and then turn a profit on the whole proposition? Because that's ultimately what your sales model is.
It is. The way I would answer that is that EcoVapor, we try to be flexible with our customers. There's some operators that only want to purchase equipment on a capital expenditure basis. Others have a leasing model, and EcoVapor is not going to be the one that determines this. So we've had to look at it both ways. The answer to your question in terms of payout on a fully loaded 02 E300, again good for 300,000 cubic feet a day. On a lease basis, it pays for itself within 4 days of the month. The rest of the month is
4 days.
Pure profit. On a sold basis, again fully loaded, payback within 2 to 3 months.
Wow,
that's a very fast turnaround.
We've unlocked a value stream that is, in my for my scale, significant.
And then getting to the product, I was trying to do some quick math in my head. I might be off by a factor of 10, but I think you've just described a 20,000% increase in efficiency.
It beats the hell out of perpetual motion.
Yeah, I mean, that's, and that'd be in 5-6 years. Now you have a product that can pay for itself. It's leased in 4 days if you buy it, and be able to, through authority for expenditure and such, spread the costs out to all the investors. That's probably what the difference is, whether you have those kind of contracts or not, but and who owns and who pays. But those are astounding time periods.
I agree, and thank you. And I said that we continue to have challenges. Some operators, for various reasons, whether it's a purely economic basis, whether they're up against an emissions limit, they see the value. It's nice that EcoVapor is able to provide multiple value propositions like that, including well site safety. Turning off the fireball right next to the oil tanks makes sense to me. However, the argument that I've been told from operators that we haven't won business with, that makes sense to me, it's unfortunate, but it makes sense to me, is they equate us to a $10 bill. Hey, Hans, we know EcoVapor equipment makes economic sense. You're the $10 bill on the ground. That's surrounded by $100 bills all over the place. And I have so many arms. So, do I dedicate my team to...
Right.
Where do I dedicate my team?
Well, I'm not trying to become an EcoVapor salesman, but I'm sort of coming up with talking points, and the percentage of efficiency is astounding. That the payback time period is astounding. But the other phrase you just used is to turn out the firewall next to the tanks. There's a kind of a social cost out there, and it's how the people that are voters, the people that are putting people in office, view the industry. Yeah. And nobody likes a fireball, and they just see danger. And they said, must stop this. So I would argue that there's kind of a subliminal benefit of just improving the attitudes toward the oil and gas industry by getting rid of the fireball next to the tanks.
You're talking about social license to operate, essentially, which is something we spend a lot of time talking about on this show.
That's right.
Well, I do want to point out that from a safety standpoint, COGCC rules do mandate safe distances from any ignition source, flares included, from oil tanks. It's the industry is not in any way doing this haphazardly.
But with a social license, we're talking about perceptions, not reality.
Right.
And we're trying to affect the attitudes of people that have no idea about COGCC rules or the danger of safe zones. They just look at it and say, holy cow.
Well, and as you get further away, that distance looks less and less. Right? If you're driving down the road and you see, wow, there's an oil tank, there's a flare.
That's just another point that I think that you can make within your sales pitch that to me would be pretty compelling is that this will help improve the attitudes. And it's really doing good for the environment.
And that's been one of the drivers for our clients. Interestingly, though, by far, the EcoVapor has had success on that basis from the social standpoint. Why there's a giant flare next to this highway type of scenario in Texas. There's a lot more production down there, but the big difference that I see is that in other states that EcoVapor operates in, Wyoming, North Dakota, we see this all over Oklahoma, Texas. I believe it's true also in West Virginia. They're using essentially candlestick flares. They're not enclosed. They're just burning the gas. Whereas Colorado, I believe, mandates enclosed flares. So essentially,
like burner stacks, right?
Yeah. One of the side projects I looked at when we were getting into this was at the Coors Brewery in Golden, a fine place. A fine place indeed, especially right around there.
Grew up with the Coors family, actually.
Really?
Yeah, I know them personally.
Well, this might come as a surprise, but there is actually such a thing as a waste beer digester. Waste beer is somewhat of a foreign concept, but hey.
So my brother-in-law moved to Golden?
I suppose that they're doing a lot of work, but these digesters, they will.
You didn't tell me.
They'll actually produce methane. It's anaerobic digestion, and they'll produce methane that's actually burned on site in an enclosed flare. Nobody can see it. Nobody knows that, hey, that's it's actually going on. But it's about 4 feet from a natural gas supply line. And we looked into it, and there was no, in terms of meeting WABI index specifications, in terms of actual specifications of this gas stream and going into that line. To be fair, this was small beer, pun intended, but it's an example of that. I don't know how else to say it. Fear of change. Hey, we're doing this. There's not a problem.
Right.
Nobody's calling me. There's no.
If it ain't broke, don't fix it, kind of thing.
And that's that combined with the $10 versus $100 example that I gave you earlier. Those are the reasons why this technology isn't on every well site.
So fear of change, I think 5 years ago you had a wonderful phrase. I think you used the phrase mental entropy.
Oh.
It was in the middle of one of your sentences, and I said, I like that.
Well,
there's a lot of mental entropy going on in the world.
Yeah, I mean, that's true. Mental, with some inertia attached to that. This entropy has inertia to it, and that's okay. That's part of the challenge of essentially entrepreneurship and developing something that didn't exist before. I told you the example of that really, really, really smart facilities engineer that said, look, we can't put this out there. I'm really happy to say that we are now standardized on his company's design.
That's
so
fantastic.
What does the future look like? Imagining that you have a lot of ambition, having achieved something, 10,000%, 20,000% greater efficiency in terms of materials and space and probably power inputs, all of it.
Yeah.
And that's in 5-6 years?
5-6 years from now. Let me make the case with 2008 as the 2018 as the foundation.
Okay.
A lot of work has gone into making EcoVapor's products in 2018 absolutely compatible with any application.
Right.
Any type of compressor we can put that on. No customization, no additional work required. We've tried to really, the term we call it is universalize our equipment.
And then that further reduces the payback time period, I assume.
Yeah, especially from installation costs.
Right.
There's one inlet and one outlet.
Right.
Everything else is self-contained, fully automated. There's no additional anything required. So that being our foundation for going forward, we're trying to take a Goldilocks approach from a design standpoint. Hey, do we have big, medium, small, electric powered, gas powered? We're trying to accommodate every application as easily as possible. On a facility where they don't have electric power, let's say that EcoVapor only had electric power equipment or electrically powered equipment. Well, you can bring a generator out there. My goal is to eliminate that as a requirement. And also on the scaling aspect, we're already in all major producing basins. We want to get in with all major producing companies.
Understood. Where can people find out more about EcoVapor recovery systems?
We have a terrible domain name. This is a relic of startup days, but the website is EcoVaporRS.com. 2 R's and an S at the end, stands for Recovery Systems.
Wow.
That's probably the best place. Operators can provide inquiries. Also, feel free to call me. My number is 303-906-6315. Happy to take your call.
I've got a tagline for you. We're taking oxygen out of the world one machine at a time.
And putting it in the right place.
That's right.
Peter, where can people find Vital for Colorado?
Vital for Colorado, again, is www.vital forcolorado.com.
Fantastic. Under the Learn tab, you'll find videos and podcasts, all 72 episodes. Peter, I think this is a great way to end the year. Hans, thank you for being a part of the show. Peter, it's a pleasure to do this with you, as always.
Thank you very much.
And
Thanks, Hans. Very nice to meet you.
And we'll leave you with this. Oxygen is overrated. Have a great 2019, everyone.